sklearn, random projection, Gaussian random projection. Description: the Gaussian random projection (GRP) is a dimensionality reduction technique that projects high-dimensional data onto a lower-dimensional space using a random matrix with normally distributed entries. GRP aims to preserve distances between data points while reducing the number of features. Inputs: n components, an integer specifying the desired number of dimensions in the projected space. It represents the target dimensionality for the transformed data. Apes, a float representing the desired accuracy of the projection. It determines the quality of the preservation of distances between points in the lower dimensional space. A smaller ape's value implies higher accuracy but may require a higher number of components for effective representation. Random state, an integer or none. It controls the random number generation for the projection matrix. A fixed value ensures reproducible results, while none allows for different projections each time. Outputs: X new, a NumPy array representing the projected data. It contains the transformed data points in the lower dimensional space. Steps: initialization: the algorithm creates a random projection matrix with normally distributed entries. The size of this matrix depends on the original dimensionality and the desired number of components. Projection: the original data is multiplied with the projection matrix to obtain the projected data points. This process essentially transforms the data into a lower dimensional space. Metrics: reconstruction error: this metric measures the difference between the original data and the data reconstructed from the projected space. A lower reconstruction error indicates better preservation of information. Preservation of distances: it quantifies how well distances between data points are preserved after projection. Ideally, distances in the projected space should be similar to those in the original space. Visualization plots. Scatter plot: a scatter plot can be used to visualize the projected data points in a lower dimensional space. This plot helps understand how the data is distributed after the projection. Pairwise distance plot: a plot showing pairwise distances between data points before and after projection can help visually assess the preservation of distances. Fine-tune parameters. N components: adjusting this parameter allows controlling the dimensionality of the projected space. Higher values may improve reconstruction accuracy but could also lead to higher computational cost. Apes: a smaller ape's value leads to higher accuracy in preserving distances but might require more components. The optimal value depends on the specific dataset and desired accuracy. Uncertainty methods. Bootstrap resampling: this method involves generating multiple random projections and observing the variation in the projected data. This helps estimate the uncertainty associated with the projection. Bayesian framework: incorporating prior knowledge about the data distribution into a Bayesian framework can allow for uncertainty quantification in the projected space. Challenges and fixes. Challenge 1: poor reconstruction accuracy. Sample use case: applying GRP on a dataset with high correlation between features can result in significant information loss and poor reconstruction accuracy. Fixes: consider using a different dimensionality reduction technique or pre-processing the data to reduce correlation before applying GRP. Challenge 2: high computational cost. Sample use case: using a high number of components or dealing with a large dataset can lead to high computational cost and slow execution time. Fixes: optimize the implementation by using efficient matrix multiplication libraries or exploring alternative methods for generating random projection matrices. Challenge 3: sensitivity to noise. Sample use case noisy data can affect the quality of the projection and lead to inaccurate results. Fixes pre-process the data to remove noise before applying GRP or use robust methods for generating the projection matrix.